In this video we have the integral of ln of x to the fourth. And then just to clarify here, a few things from logarithms. Applies for all bases, not just the natural log. So if I have the log of some number x, or some variable x, to an nth power, and say this is base b, there's a property that allows me to take this exponent and put it out in front as a coefficient. So this can be written as n natural log of x, whatever base you have. And of course that applies for the natural log function. Also important to know that if you have the natural log of say x to any base b, and this is taken, and I put up exponent right there, and this is the same thing as the natural log of x to base b taken to the nth power. But it's important to note that this right here is not the same thing as natural log of x to the nth power to that base. So there is a difference in between this and this. It was also the same, but those are not equal to this. This here means you take the log of some number x to a base, and then you take that to the nth power. The same thing with this. You take the log of x to base b, and then you take that to the nth power. Now in this case, you're taking the nth power of x, and then whatever you get, you take the log of that to base b. So that means I can rewrite this way. So this exponent can come over here as coefficient, so I can put the 4 here. And then this is ln of x dx. We have that integral there. And then because this is a constant, you can always bring a constant outside the integral. So bring this out here and write it like this. 4 integral of ln of x. And this is one of your basic integrals here that maybe your instructor wants you to know. So you could just put the answer there. Say this is equal to 4 times the natural log of that expression there. Now I've derived this or solved this integral go here in other videos, and it involves integration by parts. So let's just look at this one here. Integration by parts will let u equal to ln of x. So we're breaking it up into parts here, and one part will be ln of x, and then the other one will be 1 dx. And then the derivative here will be du, and on the right side it's 1 over x dx. And then my dv, or the second part, integration by parts. Okay, so first part is the u, and then we select the dv and find v. So the dv will be 1, or we just call it dx. And then integrate on the left with respect to v, we get v. Integrate on the right with respect to x, and we get x. And then the formula for integration by parts starts off with the product uv. So the first part of the answer is the product of u and v. So that'd be, I put the v first, x, and then u would be ln of x. And then it's a minus, and then it's the integral of v, and v is x, so it'll go here. And then it's du. This is du right here. So put that in there. 1 over x dx. And then this x and this x cancel. And all I have is the integral of 1 dx. Well, that's just x. So the integral of ln of x is x ln of x minus x. And then we just put it in here. This is x ln of x minus x. And I put the constant of integration over here. And that's pretty much your answer. You can multiply it through here. Multiply by 4. Be 4x ln of x minus 4x plus the constant of integration. It's your answer. Thanks for watching. We'll see you next time.